Some situations with a constant rate of change do not naturally lend themselves to being represented by the general linear function formula. For example, consider the following scenario. A high school drama club is putting on a play and selling adult and student tickets. Adult tickets are $4 each, and student tickets are $2 each. The club's goal is to earn $600 total to put towards their next production. We will let the variable A represent the number of adult tickets sold, and we will let S represent the number of student tickets sold. Since the club charges $4 per adult ticket, 4A represents the total earned from selling A adult tickets. Similarly, 2S represents the amount earned from selling student tickets. And therefore, 4A plus 2S represents the total earned from selling adult and student tickets. Now, the club's goal is to earn $600 total. Therefore, they are looking for combinations of A and S that make this equation true. Now, as an example, if the club sells 100 adult tickets and 100 student tickets, then they will earn $600 total. Similarly, if they sell 125 adult tickets and 50 student tickets, they will again earn $600. Now, in order to see all of the possible combinations, we can graph the relationship using the formula 4A plus 2S is equal to 600. This relationship is linear, so we only need to find 2 points in order to draw the line. Now, we already have 2 points. However, let's go through the process of finding the intercepts, because these are usually the easiest 2 points to find for graphing linear relationships written in this form. So, if A equals 0, or 0 adult tickets are sold, then we can solve the equation 4 times 0 plus 2S equals 600, and we see that the corresponding number of student tickets sold is 300. Therefore, the point 0, 300 is on the graph of S in terms of A. So 0, 300 is on this graph. Now, if S equals 0, or 0 student tickets are sold, then we see that 150 adult tickets have to be sold for the club to earn $600. And therefore, 150, 0, is on the graph of S in terms of A. Now, the graph relating S and A is the line that passes through these 2 points. Now, we restrict to non-negative values of S and A because of the context we're looking at. But this graph represents all possible pairs of A-S combinations. Now, if we isolate one of the 2 variables in our equation, then we can determine the constant rate of change. So, let's solve the equation 4A plus 2S equals 600 for S. And if we do this, we end with the formula S equals negative 2 times A plus 300. And this tells us that the constant rate of change of S with respect to A is negative 2, which means that the change in the number of student tickets sold is always negative 2 times as large as the corresponding change in the number of adult tickets sold. Now, since adult tickets earn twice as much money per ticket, any change in the number of adult tickets can correspond with a change in the number of student tickets that is twice as large, while maintaining earnings of 600. For example, if they sell 10 more adult tickets, they can sell 20 fewer student tickets and still earn $600. And this is formalized by this equation relating the changes in the number of adult tickets sold and the number of student tickets sold.